Hi, John Capobianco here. Let's just quickly take a look at the proof and then we'll get into the pudding. So I asked for an L2 to L4 analysis of this packet capture.pcap. It's a single UDP packet. Here's the L2 information. Here's the L3 information. Here's the L4 information. Originates from an Intel device on a local network destination for a remote host on port 9000, likely transmitted over Wi-Fi. Right now, this was a few steps here, but a lot less steps. And that's what I'm going to get into. We convert it to JSON from the base 64 from the PCAP. And then it's one step. Upload an index and then analyze. All right. Now this is retrieval augmented generation, but and I didn't switch my screen over. So let me show this to you again. Let me start again here. There's the capture, L2 to L4, L3, L4, summary. And it's just a couple steps now. The PCAP to base 64 to JSON, upload an index. Now what is this upload an index doing? And the analyze doing? Well, Google just introduced on November 6th, and today's the 7th, file search tool in Gemini API. And this is, look at, right? We can take JSON, JavaScript, Python, PDF, doesn't matter, and feed it into Gemini search in the cloud. And this is retrieval augmented generation, a fully managed RAG system. Abstracts away the retrieval pipeline so you can focus on building with a very cheap cost. This is something everyone should be excited about. So here's some initial information. All right. Here is the file search, some details, more documentation under the Gemini API docs. And then if you really want to get into it, the API reference. All right. Now I had to reference all this stuff doing some vibe coding to switch my packet, my Gemini CLI. Let me show you what I'm talking about. I have a packet buddy extension for Gemini CLI, and I wanted to switch away from my RAG process, RAG and MCP, specifically the RAG. I wanted to simplify this whole process, and you're not going to believe it. So let me show you some history of some of these files. So if I go to my requirements file, hang on. Where did the requirements? Here we go. So look at, it's three things now. FastMCP, Google Gen AI, and the Python.env to handle the environment variables. That's it. Now if I show you the history of this file, if I can find the history of this file somehow. History. It was just, it used to look like this. LangChain community, Chroma DB, Hugging Face tick token. And all of this has been abstracted away just to the LangChain Google Gen AI. The other thing is my code has collapsed from hundreds of lines of code, like 500 lines of code in my server file, to less than 150 lines of code. Excuse me, pardon me. Got a frog in my throat. So I still have tools, I'm still using MCP, but the difference here is that I can upload an index using the client file search stores, okay, with my JSON. All right, and I'm using the cloud RAG service here. So I've completely eliminated local embeddings, Chroma DB, vectors, retrieval augmented generation with conversational retrieval chains. It's RAG in the cloud. 150 lines of code to let me talk to packets. So let's try another one. I'm going to say that is great. Can you give me a CCIE level of analysis of the bgp.pcap file and give me some markdown tables to help me understand it. All right, let's see how this goes. This is not staged in any way. And you're going to see it first convert it to base 64. There we go. And then it's going to convert it to JSON and cleanse the JSON. And then we're going to invoke the cloud service to index the 6-step RAG process, transform, chunk, embed, store, and then do retrieval with a question, my question. So there's the JSON, and here's the upload and index. Okay, I've got everything sorted out and simplified and working very, very well. So everything you saw was from last night. I sort of slept on it. I had some ideas in my head, and I woke up and have refactored and made this a lot cleaner and really production grade. It's pretty cool. So, and again, I'm still dealing with packets. My roadmap here, personally, my roadmap was to start with PCAPs and then do pyATS as extensions. And I've got the PCAP extension going pretty well. So let's go in and take a look at what I mean by this. So I'm in a folder with the PCAPs, and I'm going to say, using PacketBuddy, can you help me understand the local capture.pcap from L2 to L4? Make a few markdown tables to help me understand as a novice. So it's now boiled down to a 3-step process. All right, down from like a 7 or 8 or 9 or 10-step process previously. We're just going to convert the PCAP to JSON using tshark at the command line. We're going to sanitize that JSON and drop any large hexadecimal fields, tcp.data, udp.data. Now, what we could do instead of sanitizing it that way is to maybe use base 64 and decrypt the hex as text. I'm thinking about maybe augmenting it that way. That way we can actually see both the headers and the payload of the PCAPs, but that's down the road. And now we simply call the upload and index. And what we're going to get back is a link to the cloud-hosted RAG service. Right? Now that's really cool because what I would normally be doing here is after that sanitized JSON, I would be chunking it with a semantic chunker with an embeddings model, and there's a cost to that. I would be then using an embeddings model to take the chunks and turn them into vectors, floating point numbers, so another embeddings model. Then I would need to store those embeddings, those vectors, in a vector store like Chroma DB or Pinecone or Elastic or something. Then I would need to set up a retrieval semantic search lookup for the LLM to use that data source, that vector store for RAG, for retrieval augmented generation, right? Either as a LangChain conversational retrieval chain or a basic semantic lookup against the vector store with the user's prompt. Now, all of that, everything, all that blah, blah, blah I just said, is just been abstracted as a cloud API service. Send it your PDF, your text, your JSON in my case. And as soon as I saw that it accepted JSON, I knew that I would be able to chat with packets using this new cloud RAG service. Now, whether it's any faster or not, I'm not worried about that. Here we go, we're done. So in about 2 minutes, call it 2 minutes, we have the file search store and my PCAP store and a UID, a unique identifier. Here's the analysis of that PCAP. And now here's the Gemini's answer. And here's the layer 2 information, the layer 3 information, the layer 4 information with the markdown tables that I asked for. UDP, source, destination, really cool. Really cool, right? So let's just do another one. Let's do the CCIE level of BGP and give me some markdown tables to help me understand it. Again, this will take 2 minutes. So I will pause the video once we hit that step and then come right back. Thank you for sticking around. I know that there was a little friction at the start of this video, but I have worked it all out here. So I will be back in a few seconds. Minutes. Thank you. Okay, here we go. So we have those 4 steps. Convert, sanitize, do the cloud RAG, analyze via the cloud RAG. Look, right here. Store name. Question. This is all it does. You don't understand what I've been dealing with for 2 years now, doing this by hand, artisanally, and as a handcrafted thing with a 6 or 7 step process with a lang chain, right? Upload your data and it will store it and provide it as a RAG source. And right, and here's the analysis of this BGP, right? With the markdown tables and everything at a CCIE level. Withdrawn routes. Pretty cool. So my next step is going to be, now that I'm happy with this and this works, I'm gonna be merging this into my main branch in GitHub. So the new Packet Buddy extension is now driven by this. I will be refactoring my pyATS one next. So I'll be doing pyATS next and adding built-in RAG into the pyATS code. All right, stay tuned. Okay, this is wicked. All I did was take that upload and index function and MCP decorated tool from my packet work this morning and moved it into my pyATS work. That's it. That's all I did, more or less. The next thing I did was explain to Gemini via the Gemini MD file that it now has built-in RAG. And when you get the JSON back from pyATS or the raw text back from pyATS, save it as a file and then send it to the cloud RAG service. And instead of you answering the question, you're going to use that RAG index to answer the question. And then Gemini gets to summarize and answer and reword the RAG answer. Now there's a couple of keys I'm going to point out here as we go. But this is from my pyATS MCP server, which is from my pyATS Gemini extension. And I asked if it could help me understand the routing table of this always-on sandbox. So we pass it show IP route. Now, I want to be very clear. This JSON alone worked. It works just fine. Gemini has this as context, and this whole RAG business might be an extra step that we don't need. I think it's needed. I think because we want to reinforce and augment the generation of the output as best we can from this data, as opposed to just sticking this JSON into a context window as a blob of JSON with the question, which yes, it could work, but now instead, and I'll show you in a little bit, we're going to dump this out to a Python, pyATS context JSON file. And then we're going to upload and index this. All right? And what we get is this cloud RAG. Sorry, that was my phone. 1 second. Where did it go? One second. Sorry about that. So, look at this. We get a referenced RAG index here. So, I assume that this has been chunked, and I know it's been chunked, vectorized and put into a vector store, and I don't know what the vector store is, or I don't care anymore about any of that stuff. Send the JSON to the Cloud RAG service, and then look at this is key. We're going to use that store and my original question to answer the output, right? And this is the RAG backed answer. It even references its sources. And then we get Gemini's answer here. Really cool. Really, really cool, right? All right, I'll be back with more of this. Stay tuned. Okay, let's have a little more fun with this and say, can I get a markdown table of the interfaces? And I'm going to show you the process that occurs now that we've added the RAG. Now this is almost guaranteed. Okay, well, yeah, so it sort of already did that. So it can read the context JSON file. I see. So we already have the context. So let's say, how about this? Can we get the running configuration of the device and look for opportunities to improve the security posture? All right. So what this should do is trigger pyATS show run, and then it's going to save that as just raw text, and then upload it to the Cloud RAG service and give us a new file reference. So that you can see there it's happening. It's running the show run. There's the show run. And now it should dump that out to a text file, I hope, since it's not JSON. Let's see what happens. Executing the plan. Come on, let's go. Okay, here we go. So it's going to, it's going to write it out to running config.txt. Cool. And now we've hit the uploaded index. So we need to wait, 90 seconds, 2 minutes, 60 seconds, somewhere in that range for this to finish. And I'll come back to you with, so what we're going to get from here is the link to the Cloud RAG service. And then we're going to follow it up with that question I posed against the RAG service. That will give us a retrieval augmented generation response that then the Gemini CLI can interpret as natural language back to us, the users. All right, I'll be back in a minute when this is done. Okay, here we go. Just a couple seconds later. Analyze. Right now, look at the analyze. I want you to pay close attention here. We're using that store name. We're passing it that vector store name that we got from the index and upload, and we're querying it for security posture. Here is the RAG initial analysis, and it has the sources and the store. Now we get this wonderful breakdown of enabling port security, implementing storm control, using STP enhancements, disabling default VLANs and unused ports, for segmentation, some management plane security, some other general security practices, all based on the analysis of the running config of this one device through natural language augmented. All right, so I don't know what all this is. I'm sorry about all this here, but I started with, can we get the running config of the device and look for opportunities to improve the security posture? PyATS gets the running config via MCP. We then save it out to a file. We then upload and index it in the cloud file search service from Google that gives us a file search store reference. We then do the RAG against the file search store reference, and then finally get the Gemini CLI interpretation. So we've gone from PCAPs to pyATS and anything you want on a router or switch or whatever pyATS supports. Pretty wicked, pretty wicked. So I am, I'm not sad that all that RAG work has gone, obviously been made obsolete. The process I'd made in Packet Buddy and all this stuff. It actually is easier now. It's simpler now, and it's taken me no time to refactor, and it should take you no time to start using RAG as a cloud service. All right, thank you so much. I appreciate you joining me on this.